Section 1.2 Piecewise functions. Many times we deal with functions that change the way we act over a time interval. For example, cell phone usage. A cell company may charge less for the first 100 minutes of use and more for any usage after that. This is a great example of a piecewise function. Let's take a look at a few examples. Notice that in these two functions, the common point will be 1. Okay, so if you notice that the top function, 4 minus 2x, acts like this as long as the function is less than 1. And it acts like the bottom function when x is greater than or equal to 1. So let's see where these two functions meet at 1. So we're looking at x equals 1, which is right there. If you plug 1 in for the top one, you're going to get height is going to be equal to 2. If you plug 1 into the bottom one, you notice that the height is going to be equal to negative 3. So notice that these two functions will not meet at x equal 1. Notice that the top function at 1 will have height 2, and since it's not inclusive, it will be an open dot. So that would be there. And notice that the bottom function, when it gets to x equal 1, would be equal to negative 3, and that is inclusive. So notice, as this function here, if you'll look that the slope is negative 2, so if you do rise over run, you're going to see that this function is coming in like this to the open dot, and the slope of this one is 1, which is 1 over 1, so it's going like this. And so here is a good example of a piecewise function where the left function is coming down, the right function is going up, and notice they do not meet in the middle. Notice in our second example, h of x, we have 3 different functions. Now notice that our points in which one function is tying into the other function here is going to be 15, and at this one it's going to be at 50. So let's take a look at these points and see how they react to these two functions. Notice the first function, 2x, at 0, so if you plug 0 into 2x you get 0. So we have x is 0, 0, so that is our starting point of the first function. Our ending point of the first function, if we plug 15 in, so 15 is going to be our x value. If we plug 15 in, we'll get 30 out for the second one. So if we plot 15, 30, we're going to end up about right there. Now notice, it's got equals or inclusive in it, so it is a solid dot. So this function, so the first function looks like this, where it ends at 1530. Okay, looking at the second function, if we plug 15 in, so the second function we've got 15, comma, and we'll have 15 plus 15, which would be 30. So we've got 1530. So notice these two functions meet at the same point, but this one is not inclusive, so it's going to be an open dot starting there. If we plug 50 in and put 50 plus 15, which would give us 65, we would get 65 out. And if we plot 50, 65, we should get somewhere in here. And notice the last function, if we plug 50 into the last function, half of 50 is 25 plus 30. So if we plug 50 in, we should get out 55. And if we plot 50 and 55, we're going to get somewhere in here. And notice that's an open dot. And notice that the slope of this one is 1/2. 0.5 is the same as 1/2. So if we rise over run 1 over 2, so notice that this line is going to be flatter heading out into infinity. So notice, if we look at this graph, we notice that the 2x, notice the slope is steeper here because the slope is 2 over 1. Notice here the slope is 1 over 1. And notice here the slope is 1 over 2, or 0.5. So notice that this thing is getting less steep. Also notice that there's no connector in there, whereas here these two things connect even though one's inclusive and the other is not. These are two good examples of piecewise functions.